Hi, my name is Hugh McKee. I'm a developer advocate at Lightbend, and this is the part 2 video of actors living in a cluster, which is part of the How Akka Cluster Works series that I've been doing, a video series I've been doing. So we did part 1, and now we're going to jump into part 2. So what you learn in this, in part 1, we looked at how actors work throughout a cluster, and then how actors balance their workloads across a cluster, which was digging into what's called Akka cluster sharding. Now in part 2, we're going to continue on, and we're going to look at things like what is actor passivation, and why is that essential. I think one of the more interesting things that we'll cover in part 2 is what happens to actors when nodes fail. And in particular, I'm going to show you what that means with cluster sharding. And then we'll wrap up with some real-life examples of entities, things like that. So the setup here is the same for part 2 as it was for part 1. There's a sample project that I'll be using that you can grab off of GitHub. The URL here is down here. In order to get this, you're going to need Git, you're going to need Java 8 and above. Java 11 is probably a good place to go. And Maven. We build this with Maven. So want to kind of jump into a demo, so let's just go ahead and grab the project and build it again. So if you haven't looked at part 1, I'll just kind of quickly go through grabbing this project from GitHub, cloning it, building it, and running it. So I'm going to do the clone on my local system and get that project. And I'm going to jump into that directory and do a Maven clean package to build it. It builds a standalone runnable jar in this POM. It's up to do that. And also what's included in this project is a bunch of Akka scripts for running this demo, trying to make it easier to run a cluster on your machine. So there's, if you look at this Akka script, there's a number of different commands. The subcommands, the one I'm going to use right now, I've covered this a lot in the first video and in even more detail in other videos I've done in this series. So you can check those out if you want to get more information. But to start a cluster, I'm going to just do Akka cluster start. That starts up a cluster of 9 nodes, and I can kind of check the status of this command line here with this Akka cluster status. And what we should see here is some JSON that pops out when the cluster comes up. There we go. We've got some nodes running in the cluster. And what I want to get running here is, we also saw this in part 1, is this viewer of a running cluster. So this is just some JavaScript that I wrote that comes with this project. And it's a visualization of actors running in the cluster. So I'm going to turn off some of these trace lines that are part of this whole thing, and to kind of slow things down as far as how much it has to draw. I've got a lot of things running on my laptop, and we'll leave it right here. So I'm going to go back to now we got it running, and we'll go back to the slides, and we're going to jump into the part on passivation. So with passivation, what this is that you can, especially with cluster sharding, you start up actors, and they get started up when messages get sent to them by cluster sharding as part of the abstraction, as part of cluster sharding. But what about getting rid of these actors when nothing's happening? They're not receiving any messages anymore. So that's pretty straightforward. So I'm going to go back to the code example for a bit, and we'll go to the main. I'm going to go back into the main class where things got to get bootstrapped. And just to follow through again, there's a main method where we create an actor system. And in that actor system creation, we create a root actor, which is the tip of an actor hierarchy, which is in this class. So this class also behaves as the root actor. go into a create method, which invokes a bootstrap method that I wrote. And in the bootstrap, it starts up a bunch of actors that we talked about. But what I wanted to show you was setting up cluster sharding. So I'm going to jump down to this method, which is also in the main. And here I'm just writing, starting up cluster sharding. So you get reference to cluster sharding just by saying cluster sharding get, and you pass it the actor system. And then in cluster sharding, there's an init method. And in the init method, you're really just doing this entity of, and there's a number of different things you have to set up. But really what I want to focus on is here, is this entity actor. Because this is all, these two videos are all about kind of the dynamics of actors. So you can look at the documentation on cluster sharding and so on to get more details on that. But what I want to focus on here is this entity of is, the way I kind of look at it is kind of a factory. You know, you see the second parameter of the entity of is this lambda that is being passed. So this lambda is executed anytime a new entity actor needs to be created. And you can see that I'm passing in create. I talked about actors and static create method a lot in part 1. The create method is a common pattern to use for creating new instances of actors. So now there's this new actor we didn't look at it part 1 called the entity actor. And I'm passing in a couple of parameters, the entity ID and then this HTTP server ref, which is, you know, I'm passing in this actor, this HTTP server actor, because this is the actor that is fed stuff that's happening in the cluster so that it can be visualized. So let's take a look at the entity actor create. The create is pretty straightforward. It's just doing a behavior setup, and you know, it's just creating a new instance of the actor, giving it the actor context, the entity ID, and the HTTP server actor ref. That goes down to a private constructor, and we set everything up. So what this actor is doing is, if you recall from part 1, in part 1, there's another actor that's sending messages to entity actors. That other actor is this entity command actor, and there's an entity query actor that's very similar. There's just in one case it's sending commands, in the other case it's sending, you know, supposedly query requests, but they're functionally very similar, mechanically very similar. But what happens is that, you know, these guys are using a scheduler to do regularly sending, like it's a configurable setting how often the scheduler runs, but this triggers this actor to send messages to entity actors. So up here on this line, line 48, it's creating an entity ID. There's a little algorithm, a little bit of randomness, but it's a subset of range of entity IDs that this particular entity command actor is creating, but it's sending new entity actor messages to entity IDs, basically. And he's using this entity ref tell. So I covered this in part 1. Now in part 2, this is the sending end. In part 2, we're looking at the receiving end. You know, the entity actor is created by that factory method here, back in the main. You know, this lambda entity context, and pass in the entity ID and the HTTP server ref. So like I said, anytime a message needs to be sent to an entity actor that isn't alive and running somewhere in the cluster, then this lambda method will be, function will be invoked and will create an instance of the entity actor. So the entity actor is very much like the other actors we talked about. Do a little bit of setup in the constructor. Then there's this create receive method that we need to override. And then in the create receive, we're defining with a new receive builder what messages this actor is expected to handle and expected to receive. So there's a change value, a get value. So the change value is coming from the entity command actor. The get value is coming from the entity query actor. And there's also a passivate, which we'll look at, and which is what we're looking at right now. So the passivation is the part where this actor will shut itself down after a time of not getting any messages. So how is that set up? It's really quite simple. In the application conf, in the cluster sharding section, there's a setting that you can override. I think I forget what the default is. I think it's like a minute or something. But passivate idle entity after. So what this means is that after 15 seconds, if a given entity actor does not receive any messages, then it's going to shut itself down. It's going to passivate itself. So in the entity actor, what will happen is that it will receive a passivate message. And this passivate message invokes this onPassivate method, which then does a behaviors stop. So behavior stop triggers the shutdown of a entity actor that hasn't received any messages for 15 seconds. Again, this is a demo. It's kind of contrived, so I've got the passivation time fairly low, but this is something that you would configure based on the behavior of your own entity actors. In many cases, you want these entity actors to stay around longer because it might be, say, it's a shopping cart entity actor, and you've got a human out there in the real world that's using some kind of an app or something on their phone or some type of device, and they're triggering actions on that device, which ultimately send messages to an entity actor just for them. Like for my shopping cart, I have an entity actor. For your shopping cart, you have an entity actor. For somebody else's shopping cart, they have another entity actor. And when we're, say, adding an item to a cart or removing an item from a cart, or different actions we're performing on the shopping cart, those can come in at some interval. And it could be that, well, if you haven't heard from the user for, say, 5 minutes or 10 minutes or whatever you think is the right amount of time, then you can have those entity actors shut themselves down, which means they remove themselves from memory. So you can see the passivation happening in the viewer here, where as you watch what's going on, you can see that these blue circles on the perimeter, which are live entity actors running on different nodes in the cluster, and there's 9 nodes running right now, that at times some of them go away. So there's a kind of about a 5-minute refresh cycle here. And what will happen is you'll see some of the entity actors kind of pop, kind of vanish. They fade away in a little burst of light red. And those are actors that have not received a message for 15 seconds or more. And they then receive a passivation message from the system, from the Akka system, to notify the actor that it should stop itself. That causes the actor to shut down, which means that it'll go away. It'll eventually get garbage collected by the JVM, and it's gone. So that's the idea here, is that these actors come and go, and they come to life when a message is sent to it. The cluster sharding handles that, where when a message is sent to an actor, that Lambda function back in the code in the main is invoked. Go back down here. This entity actor create for specific entity ID will be performed on the node where that entity actor is going to run, and then it will receive that first message, and then from that point on, it will receive subsequent messages, and the entity actor will stay in memory for as long as it's actively receiving messages. And you define what active is by that configuration setting that I showed you earlier, where, like for this demo, I set it fairly low at 15 seconds, but as I mentioned earlier, you adjust that setting that makes the most sense for the behavior of how your entity actors are used. And then that's it. And then what will happen is, if an entity actor leaves the memory because it was passivated, because it got bored, it hasn't received any message for a while, And then at some point later on, it gets a message again. The cycle is just repeated. It will the entity actor will be created. It will start receiving messages, start processing. Now, when in a real type of a system, normally these entity actors have persistent data. So we're using something like Akka persistence, where the state of the actor, like the state of my shopping cart or the state of your shopping cart, as changes are being made to that shopping cart, those changes are being persisted to a backend database. But while the actor is alive, the state of the thing, of the entity, is in memory, and it will stay there as long as it's needed. So that's a form of optimization, because instead of like in a stateless system, which is a very common pattern, nothing wrong with it, except that you are paying the price of every single request coming into the system. Like every time you want to add an item to that shopping cart, you're going to have to go to the database, retrieve the state, pull it into memory, make the state changes, persist any changes back down to the database, and then you throw the state away. And then the next message comes in, and you repeat that cycle over and over again. With entity actors, by design, they're stateful, meaning that the state of the entity is in memory, so we don't have to keep retrieving the state every time a request comes in. So if my shopping cart, I'm interacting with it, it's hot. My state is hot in memory in the actor, and we have that bit of optimization where we're not having to retrieve the state every time from the database. So that's cluster sharding. I think it's really, really powerful, and it's a very, very common thing to use, and it does a lot of work for us as developers, where we really focus on writing, for the most part, the business logic, the logic of the entities themselves, and let Akka cluster sharding handle all the message routing and bringing it, starting up actors, entity actors, stopping entity actors, passivating them, just redistributing them across the network, all those types of things. So let's now move on to the next topic, which is what happens to actors when nodes fail. How do they maintain their state? So to do that, I'm going to go back to the viewer, and start up a viewer again on this page here. And in the viewer, again, I'm going to turn off all these lines. There's a little feature that you can use if you're playing with this, or if you want maybe to demo this to others, where you can see the action of, follow the action, I guess, in the case of a failure. So I'm going to turn off the lines, and what you can do is you can randomly pick any one of these entity actors. I'm going to pick one of these ones running on node 3. And it's like a little laser pointer. If I click one of these entity actors, it turns red, and its associated shard turns red, because this entity actor 2559-5, which is the entity ID, will always be associated because it hashes to shard 5. So what happens when node 3 here stops? Well, to do that, to simulate this, I'm going to stop that node, and I can do it from this user interface by going up to the top left and just click node 3 here. So we should see node 3 go away here in a moment, and all the entity actors who were running on node 3 stop because they're gone. Now, what happens really pretty quickly, and we saw it already happen here, is that shard 5 immediately was brought back to life on node 6. Now, what node a given shard will pop up on is really up to cluster sharding. There's no code that I wrote as a developer, that you write as a developer, that we have to worry about this, that this is just a feature of cluster sharding. So what happened was that all the entities that were running on shard 5, for example, died on node 3, and Akka saw that, cluster sharding saw that. Messages were being sent to the entities, all these entities in shard 5, including the one I'm tracking here, 2559-5. So when those messages were sent, and now the decision had to be made, well, where do I route this message? And now internally within cluster sharding, it realized that some redistribution has to occur, and it very quickly decided, all right, well, shard 5, it isn't around anymore. I'm going to have to redistribute shard 5. So shard 5, it picks node 6 to run it. And then the messages start to get forwarded to shard 5, which then forwards them on to their, its associated entity actors. Those entity actors get started up using that lambda that we looked at in the main, and we continue running. So this is really a powerful feature, right? Where there's really no code, as I said, that we write as developers to do this, and we don't. It's a kind of a non-problem, So we lost a node, and we had some entity actors running on that node, of course, and they stopped abruptly for whatever reason, maybe because of a failure, maybe we're just scaling the cluster down because we don't need all that processing capacity. Whatever the reason, cluster sharding takes it in stride and moves the entity actors and the shards and their associated entity actors to other remaining nodes in the cluster, kind of rebalances it. So you can see now that instead of having kind of a there's 18 shards and there were 9 nodes running. Now there's 8 nodes running, and a couple of the nodes, instead of having just 2 shards on them, there's a couple of nodes that have 3 shards running on them. Now, so the other part, and I want to go back to the slide for this, is that the state has to be recovered, and this is something that is handled by Akka persistence. And Akka persistence is a topic for a whole nother video, which I'll be doing in the future, but I just want to reference it here. Here's the documentation to it. And I mentioned earlier that normally in a real application, the entities that you're building have some state that you don't want to lose. So in order to do that, you persist the state into some kind of a database using event sourcing, which is a part of command query responsibility segregation, CQRS, which is a really interesting alternative to CRUD, which is the very standard, very tried and true, great read, update, delete pattern that probably all of us have been using since we've been developing. In any case, that's what Akka persistence does. So the state of the entity actors is being persisted as changes are occurring. Not in this demo, but I've got other demos that do use Akka persistence. But in this demo, everything is just in memory, and it's a trivial, lightweight type of a solution. But the mechanics are the same. That the entity actor is persisting state changes to a database, so that when the entity actor has to be resurrected because it was passivated, or resurrected, and by that I mean restarted because it had to be moved to a different node, then it triggers an action to recover the state from the database, get the entity actor state back to current state, and then continue to process messages from that point on. So that's pretty much it. It's really quite straightforward. It's just it's a key feature of cluster sharding that just takes the burden of responsibility away from us, that we don't have to worry about it as developers, and handles very elegantly, I think, in cluster sharding. So finally, let's wrap this 2-video series up with this last topic, which is how actors model real-life entities, like a shopping cart or say an IoT device, or such as a smoke detector or something. And this is actually pretty straightforward. And I'm going to show you the version that I have in the demo project, and then I'll show a version of a project I'd like to cover in another future video in more detail at the code level in another project. But it really has to do with the idea of state. So in the slide, I have a link to a part of the Akka documentation. It's called the object-oriented style. And there's kind of a functional style and object-oriented style of actors. Both of them are very interesting. But for actors that are stateful, it's more of this object-oriented style, which, because that's really what it is. We're writing an actor, which is an implementation of a class, and we want to maintain some information about the thing that the entity represents. So we're basically using good old object-oriented types of programming, the stuff that we should do all the time. And that's what I'm doing here. And I just kind of formalize it. I mean, in this demo, I created a internal class called state. In this demo actor, it's really quite simple. I maintain a date, just a date field. It's just something to have a state. But in a real type of application, the state would be like, all the information associated, say, with a shopping cart, or all the information associated with a given device in an IoT type of a system, maybe a sensor of some kind, a smoke detector, whatever it might be. And it could be whatever the interesting state is about that device in an IoT system. Now, the one I wanted to show you here, though, is this other sample class here. It's called, it's in a different project. It's another set of projects I've been working on, a demo project called Where on Earth, which is a map-based IoT type of a simulation. And this is using Akka persistence. So Akka persistence takes the object-oriented style a little bit further, and it formalizes a bit where you define things like commands and events and states. So you can see that defined here on line 27, that when you're defining what's called an event source behavior, you have to provide these things. So in my case, I wrote this actor, which is called the device. It's some kind of simulated IoT device. And I've got a device state. And this state in the device, if we take a look at it real quick, it's also fairly simple, but it does do persistence. So it is using Akka persistence. So the state is things like where is it located on the map, which I call it a region, and its state is either happy or sad, and it has an active state. And that's kind of it. It's still fairly simple, but this sample project is using Akka persistence. So again, the state is something that is very object-oriented in a way, that we're writing a class, the instance variables in the class typically hold some kind of a state. And when you're using Akka persistence, like I said, it formalizes a little bit more in that you have to actually declare some kind of object that is the state of the thing. And that's pretty much it. So in a future video, we'll be covering Akka persistence in more detail, and we'll be diving into that in more detail. So if you're interested, take a look at the object-oriented style. And I think in the last slide, I also had a link to event sourcing. And those things really cover this in a lot of detail. But that's kind of it. Actors, maintaining some kind of a, what's a real life example is things like, in a shopping cart, the entity would have object instance variables that define the items in the cart, the shipping address, the billing address, just basic object-oriented stuff. It's really nothing more than that. And that kind of wraps things up. In these two videos, part 1 and 2, we covered quite a bit of material. Things like how actors work throughout a cluster, balance the workloads across a cluster. Both of those are cluster sharding. Passivation is also part of cluster sharding. And what happens, what I showed you when actors are running on nodes that fail, how does that handled as well? So kind of one of the things that kind of came out of this, the star of the show in many cases, was cluster sharding. It is a very powerful feature of Akka. And then on a more basic level, we looked briefly at how actors model real-life entities. It's fairly straightforward, just taking what you know about programming and object-oriented programming for the most part, and using that with Akka and things like Akka persistence and cluster sharding and other features of Akka. So hopefully you found this interesting. What's next? Well, one thing you could do is I'd love to, I created these projects, and I'd love to have you grab the project and play with it. It's one of a series of projects. They're all there. I try to make them as lightweight as possible to where you can grab it, clone it on your local system, build it and run it, and there's that eye candy piece to it with dashboards and in this project there's also, in addition to the dashboard, there's the crop circle cluster viewer, as it's called. Also, go to the Akka website. There's tons of documentation there. I know it can be overwhelming, but one thing, I think I use the documentation all the time myself. I'm always in the documentation. But you can go in there and there's just lots of different things as reference material. Go there when you need to look up something specific. The search works pretty good there. And there's also lots and lots of sample projects, other sample projects that are referenced off of the Akka documentation. Some really excellent sample projects. So there's a wealth of material there. And as always, you can contact us if you want to talk to us some more about using Akka, working with us as a customer, or just schedule a demo. Here's the link for that. So I really hope you found these 2 videos useful. Again, my name is Hugh McKee, developer advocate at Lightbend, and here's some of my contact information. Thank you very much.